व्हॉट्सअपला पाठवले सर, बघितलं ना तुम्ही सर?
हो हो.
मला वाटतं लोक इन होऊन राहिले आता.
हो ते 9:50 टाइम ठेवलंय ना त्यामुळे.
हो पाठवलं ना तुम्ही मेसेज?
मेसेज पाठव. हो हो आहे, व्हॉट्सअपला आहे, मी पाहतोय. हो पाठव.
सरांना मला वाटतं 10 मिनिटं लागेल, वेट करूया.
हो
10-15
चालेल.
मिनिट. हो हो
सरांचा मेसेज आला का?
हो मेसेज आलाय सरांचा.
ठीक आहे, लोक वेटिंग रूम मध्ये आहे.
आधी पार्टिसिपेंट अलो करून द्यायचं की नंतर सरांना करायचं, कसं करायचं?
नाही नाही, सर आले की मग पार्टिसिपेट ना अलाउ करू.
ठीक. सर सरांना कोर्स केलंय का? सरांना कोर्स करून द्या ना मग.
हा राजन करतोय तुमचं.
सरांना म्हटलं कोर्स केलंय का?
हो केलं.
हो. 10 मिनिट, मला वाटतं 10 मिनिट लागेल सर. 10 मिनिट लागेल.
हा ठीक आहे सुरू करून.
हो, त्यांचं कधी आवडत असेल ते.
Hello.
Yes.
Sir, actually, I just got a message that message me that we will start at 10:30.
Okay. Yes. So we will wait for 10-15 minutes.
Huh?
We will wait. We will up to that time then.
Yeah. Like sir, message me we will start at 10:30. So I don't know what was the scheduled time and how much like sir.
Okay.
You just estimate and accordingly just communicate to the participants.
So shall we start with the sir's introduction, or shall we wait?
I think it's almost half an hour. So I don't think that you will take 30 minutes to introduce Professor.
Okay, okay, no problem.
Once sir join, after that we'll start with the
Yeah.
introduction.
Yeah.
Yeah. So we'll hold on and participate will keep in the waiting room only. Once sir join, after that we'll allow to the participate. Is that fine?
Okay, but do you need? Do you think that you should communicate to the participants also?
Yes, yes. So we are passing the message in a Telegram that we'll start the program in at 10:30.
Okay, perfect.
Okay.
Thank you.
Rajan. राजन.
हा सर.
काय करतो टेलिग्राम मध्ये मी 10:30चा मेसेज टाकतो. ठीक आहे. मी 5 मिनिटाचा टाकला होता. तू काय कर टेलिग्राम मध्ये विल स्टार्ट प्रोग्राम ॲट 10:30 बिकॉज ऑफ सम टेक्निकल इश्यू. ठीक आहे.
मी तुम्हाला कॉल करतो.
ओके.
हॅलो. हा, त्यांचा मला मेसेज आला की वी विल स्टार्ट ॲट 10:30 सरांचा. बरं, की थांबावं आपण तसं, कारण की कसं मग लोक निघून नाही गेले पाहिजे. हा, बरं ठीक आहे. काल लोकांना मेसेज टाकून की वी स्टार्ट इन 10 मिनिट्स असं म्हणू का? काय गरज नाही. मला वाटतं सरांचं ते आवरण वगैरे सुरू असेल असं वाटतं. मुलगा तिथे बसलाय, तर काय म्हणून वी विल स्टार्ट ॲट शार्प 10:30. बरं ठीक आहे, चल टाकून देतो. बरं ठीक आहे ना, मी मेसेज टाकून देतो. हा हा.
हॅलो सर.
ठीक आहे, येतो ना आवाज?
हो येतोय. चौधरी सरांचा मेसेज आलाय. कॅन यू अलाउ मी टू शेअर द स्क्रीन?
ठीक आहे, सरांना इन करून द्या मग.
नाही तो 9:42 सॉरी सर.
जुना असेल ना?
जुना आहे जुना आहे.
हो.
ते इनच आहेत आपल्याकडे.
ठीक आहे.
ओके.
हॅलो, करत आहे. हो.
के बात करेंगे. Hello, hi Rajan.
Yes, sir. Shall we make the participant to in the window, sir? Okay.
Start video from that, of course.
Good morning, sir.
Good morning. How are you, Rajan?
Yes, sir. I'm fine. How are you?
I'm fine.
Yes.
So he's your colleague. I'm seeing one more person. I think he's your colleague, Rajan.
Yes, sir. He's handling the online the software Zoom.
Okay.
He's our faculty.
Okay. Hi.
Yes. We have one more coordinator for this course, sir. Professor
Okay.
Amarsi Lange. Yes. He will also join and he will introduce your profile to the audience, and we will just introduce you in 5 minutes,
Okay.
and then we will move to the actual session of yours.
Okay. Sure.
हे जे केलंय पार्टिसिपंट अलो केलंय ना.
So your number of participants, I think 166 participants.
Sir, actual registered participants are 1,000.
Okay, great.
And on screen they are joining in the quantity of some 550.
Okay, good.
Yes.
So they are from different locations?
Yes, sir. They are from different locations within the India. A few are from Maharashtra. Some are from Hyderabad, Bangalore.
Okay.
All over the India.
Okay, most of them are faculty members.
Most of them are faculty members, sir. And few of them are doctorate also. Means we have near about 30 to 40 participants at the doctorate.
Okay. Good,
and they are working at reputed institutes as a faculty.
Okay. Good. Great.
And we received good response from the all the participants, sir.
Okay. Very good. And how is your work going on? You're doing some research here?
Yes, sir. Yes.
Okay. I think last time we met, when you came Indore, I think.
Yes, sir. We met at Indore.
Indore.
Before that, we met at, I think,
Ropar.
Yes, sir, Ropar. Then I also gave some interview at Delhi also, sir. Delhi, then Indore.
Okay.
Yes.
Okay. It's okay. Every place is.
Yes.
So you are right now in Government Engineering College, no?
Yes, sir. I'm working in Government Engineering College.
Which place?
Now I'm at Nagpur.
Okay.
Nagpur. Previously, I'm at Karad.
Okay,
Government College in Karad.
I think Karad Institute is also quite old institute, no?
Yes, sir. It is the oldest institute in Maharashtra.
Okay, because I heard about
it. Is something 1960 establishment.
Okay. And right now your institute is in Nagpur only?
Yes, sir. Nagpur is the new institute started by Government of Maharashtra.
Okay.
It is started in 2016.
Okay. Great. Good. And so what is the faculty strength in civil discipline?
In Nagpur, we have some 6 to 7 faculties, sir.
Okay.
And per branch, we are having the capacity of 60 students. 60. So we have the 5 branches at Nagpur. Yes.
So you're getting good students?
Yes, sir.
You're getting good students?
Here also, yes, sir. We are entering this.
The quality of the students?
Quality of students is good, sir.
Okay.
Because we are the government institute, so all topper students comes at the government institute first.
Oh, great. Good.
So we have some 7 to 8 government engineering colleges in Maharashtra. So the first preference of the students remains to the government institute.
Okay. Good. Mr.
Hello. Yes, sir. Please log in.
Yeah.
The participants are joining now, so we are making them in.
Okay.
They are waiting. Yes.
Okay. Good.
Yes, sir.
Sandeep sir, please unmute yourself.
Yes, sir. Sandeep, sir.
Yeah, I'm there.
Yes, sir.
Sir, good
Sir,
morning.
Professor Lange, sir.
Okay.
He
Hi.
is also
Hello, sir.
faculty. He is from Government Government College of Engineering, Karad.
Okay. Good.
Yes.
I don't know. I met somebody from. I think the present NPIU coordinator is from Karad.
Yes, sir. Yes, Professor
Oh.
Kunnu, sir.
Professor,
Okay.
And sir, NPIU that
Central Advisor, Professor
we are having the
Khodke.
professor there.
Professor Khodke. Now
Yes,
I realize.
yes.
I recall because I happened to meet him a number of times. I was TQIP coordinator here.
Yes,
Yes,
sir.
sir.
He used to tell about Karad. So I was just
Yes,
trying
sir.
to recall somewhere I have.
Before joining NPI, he was in Karad only. Yes, sir.
That is why
Yeah.
now I could relate.
Yes, sir. Sir, shall we start?
Yeah,
Yes,
we can
sir.
start.
I will allow the participants.
Sure.
Good morning, one and all, and I welcome all of you on first session of third day of this faculty development program on advances in civil and structural engineering. Friends, for today's first session, we have resource person, Professor Sandeep Chaudhary, Head of Civil Engineering, Indian Institute of Technology, Indore. Before proceeding for his session, let me give his brief introduction. Professor Sandeep completed his graduation from MBM Engineering College, Jodhpur, Rajasthan. And after that, he completed a Master of Engineering from MNIT, Jaipur. And he joined IIT Delhi for PhD. And actually, his coursework was excellent. And he completed his doctorate with 10-point CGPA. And after that, he completed his postdoctorate research also from KNU, South Korea. Professor Sandeep having a wide experience in the teaching, research, and consultancy. Specifically, his research interest area is steel concrete composite structure, strength, durability, and microstructure of sustainable and functionality graded concrete. Before joining IIT Indore, Professor Sandeep has worked on a different capacity. Earlier, he was a lecturer at MNIT Jaipur. After that, he was a reader and then promoted as associate professor. And presently, he is working as a head of civil engineering at IIT Indore. Professor Sandeep having excellent publications in various international peer-reviewed journals, and it's around 60. And he has also chaired the different national and international conferences. He is also editor of 3 books. Professor Sandeep has handled different research projects and worked as a principal investigator, particularly project on the development of the highly efficient processor and GUI equipped software for the service load analysis composite structure. Professor Chaudhary handled the international as well as international consultancy project. He is also actively involved in Department of Science and Technology sponsored project. In the name of Professor Sandeep, different patent filed, specifically fly ash-based geopolymer concrete incorporating rubber tire fibers as partial replacement of natural sand, thereof useful for construction and infrastructure industries. And another patent, recycling fine bone china product based as supplementary cementation material, pozzolana. Professor Sandeep guided 7 PhD students and around 40 MTech students. Being a teacher, he has taught structural analysis, finite element method, solid mechanics, and as well as he has developed various course material and worked in collaboration with ASEAN Concrete Federation, Kusan National University, Hong Kong Polytechnic University, Thammasat University, Thailand, Zhejiang University, China, University of Edinburgh, UK, and University of Carthage, Sonia. Professor Sandeep also worked on different administrative capacity also, as well as he is a reviewer of the high impact factor international journals. Sir, I welcome you on behalf of Department of Civil Engineering, Government Engineering College, Karad, and Department of Applied Mechanics, Government Engineering College, Nagpur. Now I request Professor Sandeep, please proceed the session.
Yeah, many thanks for the elaborate introduction. I hope for a teacher, introductions are not needed. And I would like to correct, right now I'm not heading the civil department. In fact, now I'm heading Center for Rural Development and Technology, a new center which has been established. So we are trying to develop that center as from a multidisciplinary approach. And thanks to participants also, I'm seeing that there are a lot of participants from different locations. So what we are going to do for next 1.5 hours or so, we'll be discussing about the precast and prefab construction, particularly steel concrete composite construction. So what is the present status and how to move forward, and we'll look into certain aspects from research point of view wherein I have worked on those aspects. So the presentation is basically in two parts. The first part is like we'll have a general discussion on precast and prefab construction. And the second part will be focusing specifically on steel concrete composite construction, which is of course my research area also, where I have worked extensively also. So Vivek. So let me share my screen. Okay, are you able to see the screen now?
Well, kindly make it in the presentation mode, sir.
Yeah. Okay. I hope now you are able to. Everybody is able to see the screen now. Yeah, Rajan.
Yes, sir. It is visible now.
Okay.
Yes,
So
sir.
this is the first part where we'll be discussing about this precast and prefabricated construction, and second part we'll be discussing about the steel concrete composite construction. So just a minute. So if we talk about the global construction industry scenario, then we know that the construction is a key indicator of growth and investment in development of infrastructure, and this facilitating robust living environment are considered as important factors for higher growth environment. And we know that our government is committed to improve the funding budget growth in construction sector. If we talk about the global and India's position in infrastructure spend, we can see that we are quite small. And the funding, of course, the government is spending heavily on infrastructure, but still, if we compare to the countries to which we should compare, like USA and China, still the funding is quite less. Of course, there are many reasons for that. Now, we see, like particularly from Indian construction sector, the construction sector contributes around 8% in the GDP of the nation. And in India, the current deficit and demand for housing sector alone is at 3.5 trillion rupees. So the construction industry has to progress steadily in planned manner. And of course, so now if you see the current scenario, it becomes more important that you have to go for such type of construction activities which require less time and which require less human intervention. So again, there we have to think out of the box, because the traditional construction activities, they're not going to work now, because there's a requirement of more manpower at the site and there's more human contact. So we need to go for such construction where the human contact is less and where the speed of construction is fast. And that becomes more relevant. This precast and prefab construction becomes more relevant here. If you see, like in terms of the growth, we can see it has been a steady rise, but still we are far behind with the contemporary countries. And if you see the 3 successive 5-year plan average annual infrastructure, so again we can see we are lying somewhere here. The railways here, also construction is needed. Roads and bridges here, construction is there. Electricity and renewable construction is there. So in a way, construction is everywhere there in the major sectors where the government is spending heavily. And this is the like sort of amount which government is spending by contribution by various agencies. Now coming to the housing challenges. So what are the housing challenges? The housing challenges are that as on 2020, 2012, the data from where I picked, estimated housing demand was about 26.5 million units, and in the next 5 years, it can reach up to 50 million units. We are, of course, very near to 2022. So the demand can be about 50 million units. And the construction of new houses is becoming complex due to high prices of land, material, and lack of initiative in new construction method. To overcome such challenge, many countries across the world have promoted precast construction to be applied in infrastructure practices. If you recall, when this COVID started and this Wuhan episode happened, there are a lot of news about China making the hospitals within few days. So that was also a sort of precast construction or prefab construction only. So again, this and now also the governments are struggling across the world, including India. We are struggling now to make rapid constructions for the hospitals. And in fact, because of that only, they are taking this railway wagons, etc., for housing the patients. So if we have these rapid infrastructure, rapid construction practices, then might be those railway wagons might not have been required. But still, maybe down the line, we'll also develop such practices or such techniques so that we can rapidly make the buildings like China made in 3 to 4 days, a complete hospital building. It's like governments are going well ahead of us. Singapore government issued guidelines for precast construction to be used in housing system. The precast system were popular as they were found to be superior and there was a shorter construction time. So if you see the immediate urban development demand, you can see the shortage of housing units is immense. This talks about 2012 year, but if we talk about 2022, it's almost double the demand now. Coming down straight away to the precast and cast in situ concrete. So how do we define a precast concrete? So precast concrete is a construction product which is produced by casting concrete in a reusable mold or form, which is then cured in a controlled environment, transported to the construction site and lifted into place. Whereas cast in situ concrete is where we carry out the activities at the building site only. Now, the simplest of the precast concrete you can understand is like sort of paver blocks. So that's also a sort of precast concrete because the paver blocks, they are constructed at the casting yards and from there they are brought up. So we cast concrete there in reusable mold or the paver block molds or form, and then they are cured in controlled environment at those yards only. And then they are transported to the construction site or wherever we need to place the paver blocks. So that's the simplest of the example, but of course that's a very small unit. People nowadays talk about slabs, beams, columns, and so many things. We'll come down one by one to that. And if we just see the obvious advantage of precast concrete is that we can have controlled environment there and we can have a good control of the mixing, on curing, etc. But if you talk about cast in situ concrete, we might have made very good mix design. You might have done everything excellent, but in the end, if the person who is casting the concrete there is not expert, then we cannot expect the same quality of concrete as precast concrete. Another question which comes to mind is that if in precast concrete we can have experts, why don't we have the experts in cast in situ concrete? The problem is because in precast concrete, we are casting the concrete for multiple sites, maybe hundreds of sites at a single place. So even one expert is sufficient, but if we cannot put 100 experts at 100 sites. So that is another advantage. And we cannot put the controlled conditions at 100 sites. So it's always advisable, instead of going for 100 sites, make the controlled conditions, have the skilled manpower at one site, and then we just need the transportation. Now, if we talk about conventional in situ construction, majority of construction activities have sequential pattern. That's the other problem. So if we have to make another floor slab of a building, the major activities after foundation work are like casting of concrete column with double reinforcement, beam, slab level, shuttering arrangement, etc. The problem is that we cannot go for another floor slab if we have not cast n-1 floor slab, and so it becomes a sequential construction, and you have to wait for a long time. And a floor slab of 300 to 500 meters square typically takes about 30 to 45 days on conventional in situ practice. So that's a big problem. Whereas if you go in the precast construction, we don't need to wait because this 30 to 45 days, it hardly comes down to 3 to 4 days. So if it's a 50-story building, you can see that by the conventional method, it can become a huge time, maybe 3 years, 4 years. And nowadays the time is very important, so we cannot do like that. So I hope everybody's getting voice, everything is clear. Rajan?
Yes, sir. Voice is audible, sir.
Voice is audible and the presentation is also clear.
Presentation is also clear, sir.
If somebody has some doubt or somebody wants to discuss something, I think one can raise hand and then Rajan, you
sir,
can.
They are allowed to ask the question at the end of the session.
Okay, sure.
I will put the message. Yes.
Sure. So now if you see the conventional practice of floor slabs, it is something like this, which we see in our day-to-day life. Now the same practice, if done with precast construction system of floor slab, the activities will be reduced. Because after casting of the elements in a precast yard into major activities like site transport of precast unit, lifting and aligning, only that will be required. Rest of the activities will be reduced. And the productivity indices can also be improved significantly above the conventional method. And as the precast element production takes place in controlled environment, the quality of concreting, placing of service depth, squaring, etc. will happen with perfect time schedules, cost control, and best quality standards. So that is the advantage of a precast construction. Now you can see here the precast practice of high-rise residential tower. So you can see here these are precast slabs here. So quickly they can put precast slabs and precast elements. And whereas in conventional construction, it becomes very difficult and you have to wait for a long time. Here you can see factory furnished wall panels and architectural elements. So the precision you can see. Now, if you go with the conventional methods, it will become very difficult to have that precision. Maybe we can achieve this precision at 1 or 2 locations, but simultaneously at different locations, it becomes difficult. You cannot put all your experts, all your artisans, all your skilled manpower at different locations at the same time. So if we sum up the merits of precast construction, one is it's highly durable, it's fast deliverable, highly versatile. You can have any shape, any size as per your wish. It is economically affordable and it conserves materials and promotes sustainability. So overall, we can define the merits in 3 categories: quality, time, and cost. Better quality, less time, and less cost. Cost, of course, sometimes questions may be raised that it depends on the scale of that activity also. So, but at large scale activity, cost is always less. Yes, if it's a single house and if the house types are different, then it might not compete in the cost, but quality and time, always it will compete. And for large scale construction, the cost will be less, except very small constructions or very typical type of constructions which are different. Here, the cost will be less if there's a large scale construction and the type of construction is same. All the building units are of same type. So you can see this time, quality, cost, they are the merit factors of precast concrete technology. Quality, as I have already said, in case of ideal factory environmental, all seasonal effects of difficulties are eliminated. We know that those who have been working in construction or those who are working in concrete technology, we know that even in the lab, if we cast the concrete in summer or in winter or in rainy season, we get different strengths. So if it is difficult to even have a quality control or the control on the external environmental factors in our concrete labs also, then it's very difficult to have those controls in the sites. Okay, so that is very important. So we need to understand this, that when we cannot control the same thing in our academic labs, how can we control that at the sites? So the controlled conditions of factory or casting yards, use of high strength concrete and lightweight concrete or other special concrete mixes are easily advisable. There they can use easily. They can have a tight scheduling, work organization, and expert handling, which leads to more efficient quality management. There's more accuracy and better craft work for finished product is easy in factory production. You can have better type of form work because it comes the cost of form work also, because if you are having a form work for a say 2-time use, or if you are having a form work for 1,000 times use, then it depends. The cost comes down. So there they can spend on the form works also. Then mechanized ways of concrete production enables concrete products like hollow core slab, rib slabs, etc. And use of color concrete, rubber, plastic fiber, and FRP liners and steel molds can bring exquisite surface finishes. If it come down to production time, it's very obvious that production time will be less. We can crash the construction schedule to very minimal period due to robust planning, simultaneous production, and delivery of variety of products. And it requires minimal skilled labor for limited on-site works, because you need more skilled labor at the casting yard only. At on-site work, there's just jointing of the or connections of the precast elements. And there are many varieties of block making machines to produce in short time. There's a dramatically faster construction and better labor productivity, and which is established fact all over the world. That's why all over the world people are moving towards this side. Cost, material saving can be achieved because we can have optimum use of concrete to steel, and because we'll have technical experts with us and we are using multiple times the things. So material saving will be there. Saving will be on limited use of temporary support scaffolding. Saving of construction material, it can be up to 30 to 50% by innovative structural forms and design of building components, which in conventional in situ construction is not possible. The financial loss due to extended project completion can be avoided by precast construction and planning. Now, there is along with precast construction, there is another term which is used, prefabrication technology. So the use of precast concrete technology highly depends on the innovation of design of structural systems, concrete technology, and production of prefabricates. application of modern lifting equipments. That's very important. We'll come down to that, the lifting of these precast elements, that's very important. You can cast wonderful precast elements, but if you don't lift them properly, the stress distributions will change, and the precast units, they might not be of any use, or they might even fail even before application of real load. So what we need to do in precast technologies, we need to have planning. So we need to have planning, meticulous planning to use optimal resources and coordination with all stakeholders from the beginning of the project for completion. We need to focus on design, conceptual, innovative structural system with more repetitive elements and optimal quantity of materials. Fabrication, we need to achieve superior quality over conventional construction. And this is very important actually, which is not there in case of erection part, this erection part is not there in case of conventional in situ construction. So this is a very important aspect. And if we don't handle this erection part properly, then all these three advantages, they will go down. They have no use. So this part is very important. And here, of course, the conventional in situ construction, they have a slight advantage because the erection is not needed there. So we have to be very particular. And so we need to see the system of transportation and erection of elements with high safety standards. And we also need to see that the type of loads, type of moments, have forces which are going to arise in the precast elements for which they are designed. The same type of forces should apply on these elements when they are being lifted. Say if we are designing an element for say as a simply supported beam, and we are lifting it from one end only, then at that time the load is like a cantilever and there might be a failure. It can be vice versa also. So it's very important to see that the type of load which is coming finally, or type of moments which are expected finally, the same type of moment they apply on the elements when these elements are being lifted. So the places of the hooks or the type of lifting, that is very important. So the planning and design, and this is very important, and design phase is in two stages in prefabrication project. The first design phase is for service condition, and second one is for transportation and erection. So again, I am repeating, this is very important, transportation erection. IS 15916 provides the guidelines for building using predominantly prefabricated materials for components. IS 15917 provides guidelines for mixed composite construction system approach, and National Building Code of India also deals with prefabricated construction. So slowly now we have our own codes also. Maybe 2 decades back or 3 decades back, we're not having those guidelines, but now we have our own guidelines, 15916, 15917, and then NBC. So the dimensions of precast elements are of modular forms. So normally they are made in a modular form with length, width, and thickness while satisfying the design requirement. And again, this we can refer IS 15916 and NBC section 7 for modular construction. This is very important to understand the modular construction. If you are not going for modular construction, then this precast and prefab construction is of no use. So that's a basic requirement. The modular construction is a basic requirement. Modular construction means the modules or the elements individually should be in such a manner that they fit into the complete scheme of things. Okay. And site fabrication may also be preferred sometimes if transportation of element and material cost is very significant when compared to factory prefabrication. So it's not that if we are going for a precast or prefab construction, we are hell-bent that 100% construction should be precast or prefab construction. It may be 50-50, it may be 80-20, it may be 20-80. But the idea behind this is that we should go for as much precast construction, as much prefab construction. Within the boundaries where it is economical. Sometimes like for say foundation, we cannot go normally. Normally we don't go for prefabrication or precast elements. So there are certain elements where of course still, even after having very good precast and prefab elements, still we tend to go for cast in situ construction. So there is no harm. One should not always try to go for 100% for precast prefab construction or 100% cast in situ construction. There is no harm in going for a mix of constructions. So this is here you can see the precast concrete product manufacturing. So different type of precast concrete products can be manufactured at the sites. You can have, here you are seeing slip form construction of a pre-stressed slab at the site. It's manual precast floor slab reinforcement. So complete slab is this. Coming down to the important part, fabrication and erection. So what is the issue in fabrication and erection is Fabrication, of course, we need to go with the modular type of construction, that is important. But erection, the issue is like we need to look into the lifting part. And here, if we talk about the fabrication, then one of the important parts is curing. So we can go for steam curing, etc. That curing of achieved by 4 methods like conventional water ponding, water sprinklers, or mist curing, immersion in tank, steam curing, and chemical spray curing. It is very important why we are focusing more on curing, because there's a series of activities in the casting yard, and if you go for the fast curing, then even if we say instead of curing for 7 days, if we are going for a curing of 4 days and we are getting the same strength, then those additional 3 days can be used for casting other material. So it's very important to reduce the curing period as small as possible in case of precast construction, because that will bring the scale of economy. So that's why curing is given a very much importance in casting of precast elements. Similarly, this demolding also in fact related to curing. The early curing will achieve, the early demolding can be done. So demolding also is a very skillful process. 1 day or alternate day cycle is to be chosen to improve the production of precast element. And in flat elements and long span beam elements, the side shutters can be removed after 1 day and bottom shutters after 3 to 5 days. So demolding so casting, then demolding, and then curing, all are very important. And we need to reduce the time as much as possible, because here it's not like the in situ construction. Here there's another lot which is ready to be made in case ready to be made as precast elements. So if we even if we reduce 1 hour or 2 hour cycle, then it leads to a large change in the economy of the casting yard or the factory. So here, like you are seeing precast floors that negative mold, you can see different type of molds are there. You can see versatile tilting steel mold. So you can cast like that and then you can tilt it again. So this is what you can see. And again, we know that the mold, because the molding is very important. So demolding, molding. So mold material is also very important. So in case of like in situ construction, normally we don't care. We just go for plywood or timber mold because we don't need to use that for large number of times. But here, because every day there's a casting, every day the mold is being used. So it is very important how many number of useful repetitions we can have. So you can see here that for plywood and timber, it is minimum is 25, maximum 60. Concrete mold is 70 to 100, steel 500 to 2000. So depending on the scale of the industry, depending on the work order which they are getting, depending on the number of elements which they are making, one can decide whether one will go for plywood and timber mold material or concrete mold material or steel mold material. Of course, for bigger industries, one will always go for steel mold material. So this is, you can see the curing of wall panels in tank. Here also you are seeing the innovative way. So they have put in a vertical manner so that large number of wall panels and every wall panel that is being cured equally. So such type of technologies or small interventions we always need to do. And here there's an example of conventional low pressure steam curing cycle also. So here like we have a pre-steaming period, then we can have controlled heating, steaming time, and controlled cooling, subsequent curing or storage. So here you can see this entire activity takes place in just 10 to 12 hours, which in conventional manner can take 7 days to 21 days. So we can reduce the time here. Of course, there's an additional requirement of steaming or controlled heating. So there's an additional investment. But compared to the time which is saved and compared to the saving or the profit which is earned in more number of material which is being made due to the faster steam curing cycle, this investment can be a small investment as compared to that. Then stacking, lifting, transportation, and direction all are more or less related, and they should not cause quality issue in a prefabricated manner. Stacking should be done with adequate support so that element is stable under its self-weight. Again, in stacking also we need to take care. It cannot happen that we have cast a simply supported beam, the final aim of which is to replace a simply supported beam, and during stacking we put the supports some at L by 3 from each end or sometime towards inner side. So if you put the supports towards inner side during stacking, then at that time, due to the load of other beams which are above that beam, the beam will start behaving as a continuous beam. But the beam has been actually designed for or actually cast as a simply supported beam. So there might be a failure. So stacking is also very important. We need to see at which place we need to provide the support. And all elements should be protected from tensile, flexural bending, and impact during transportation. And there can be protection by means of special steel chairs or side and supportive frames. Again, these special steel chairs or supportive frames, they should be planned in such a manner that the final moments which take place or the final forces which are coming, they are the similar type of forces which we expect later on in the actual site. Then adequate number of cranes and its capacity and a single point coordination is very important. Lifting methodology, integration of elements. If you, those who have interest, if you have seen the videos, if you have gone through the news of many failures of the structure, like particularly of bridges, you will see that most of the failures of bridges which have happened in India in the last decade, they are just because of this thing, that there were certain elements, precast girders, precast slabs, and when they were placing on these columns or they were placing on the bearings, they could not place it properly. Sometimes there was a failure of the crane. Sometimes there was they placed in a wrong manner, so that when the element is being placed, it is most fragile. And because anything if happens to material, because not to material, to that element, it doesn't have any support at that time. So even a small force on that element at that time, that may cause a failure. So that's a very critical point, and where people sometimes see failures. So it's very important to have adequate number of cranes. Normally, you know that if we have to pick a 50-ton load, then our crane capacity should be at least 120 ton. So that type of factor of safety we need to take. And when we are placing the precast element, just at the time of placement, it has no other support. So it is very fragile. If anything will happen, the precast element will fall down. And that is one of the reasons, I'm again reiterating, many bridges have failed. Not bridges have failed, the elements failed when they tried to place the precast elements there. So it is very important. So you can see the precast stacking can be done in different manner, because here these are wall panels, so they have been stacked like this. It cannot be that we cast wall panels and we stack them like this. So what is the final purpose? You have to stack your panels etc. like that only, otherwise the loading pattern will change. Because these wall panels might have been designed mostly for axial load only, which will be coming. If I place the wall panels like this, then it will be sort of like slab, and it will be subjected to bendings, etc., for which it might not have been designed. So that is very important. Here you can see, like if this is a wall panel, even if it is being transported, it is transported in the same manner. Now you cannot do it like that. Though it's a wall panel, when you are transporting, you are putting it like in a horizontal manner. So one has to be very particular about this. Again, erection is very important. During erection, if you change the support conditions, failures may happen. So you're seeing this erection part is also very important. You have to put in a particular sequence, and this is a wall panel. Like if it's a vertical, then it is, when it is being erected also, it's that elevation or its orientation is not being changed. So that is very, very important, the erection part. If we come down to the economics of precast construction, then what is more important is location of prefabricated construction and its state taxation laws. Still, if you talk about prefabricated construction, and if you talk to those persons who are dealing in prefabricated construction, still many factories where bigger prefabricated elements are being cast or being fabricated, those factories are mostly located in like Himachal or Uttarakhand, where the tax laws are very good and they appeal to them. So even say if in Rajasthan or in MP, you are making some building and prefabricated building, and you order prefabricated elements, mostly they are coming from as far away Uttarakhand or Himachal. But even then, if the scale of construction is large, even then it's economical. But consider a case if the same factory is located very near to you, then it will be much, much more economical. So economy in production depends on the modes also. Because say if you have to make only 4 beams of a particular size, now it will not be economical to cast in a pre-casting yard. But if you need 1,000 such beams, then it will be economical. So it depends on the molds, because the mold should also be used properly. You cannot have a mold just for 4 castings. You should have a mold at least for 500 casting, 1,000 casting. Then the saving depends on type of contract, project, repetition of elements. It's very important. if you make your building in such a manner that the construction is sort of repetitive construction, then you will have a lot of saving. So that is very, very important actually, repetition of elements. And this table in next slide gives an idea of specification for prefabricated construction. So somehow if we see like the economy, then the economy comes in this range. So for plain floor elements, the economy is in the range of 3 to 9 meter. For rib set ends, the economies range from 3 to 24 meter. So different, like hollow core slab, it is economical in this range. So each type of element has its own economy range, like compound wall, 3 to 6 meter only. The reason is because if after 6 meter, there will be like bending stresses and so many things which will come in walls, etc. Similarly, arches, we know that arches are useful for large spans. So this arch construction, precast arch construction is, or prefab arch construction is useful only for larger spans. So every element you need to see, this is just a tentative guideline, that whether my precast construction will be economical or not. Say if I am going for pre-stressed rib slab, and for such a small rib slab, then might be this is not economical precast construction. But from 9 to 24 meter, the precast construction might be economical. So this is a rough guideline from where you can see whether you should go for precast construction or prefabrication of these elements or not. So here, like some economic indices are given, like say 6 meter span, rib slab door or truss. This span is 43.25 meter. Equivalent thickness is this. Equivalent weight is this. So these are given in the literature. So from there you can pick actually what is the cost which will be coming in precast and prefab construction. If you see typically a complete, say we make a complete precast building, this is how it will look like. It will have precast facade, precast columns, precast beams, precast partition wall, precast household shelter. They are also nowadays available. Precast parapet, precast lift well, precast refuse chute, precast staircase well, precast plank, precast gable end wall, precast air conditioned ledge, precast staircase. So everything precast can be made, and nowadays many buildings are also being made where all the elements can be precast element. Different type of prefabricated element. You can see the columns here, the beams, slabs, even staircases are also available nowadays. Prefabricated staircases, lift wall, loft. So all type of elements are available. Now, if you come down to the building systems, now we have just discussed about type of precast elements. If you come down to precast building systems, so there can be different type of building systems, and we can just define them in 3 categories: overall structural system, system for lateral load resistance, and floor and roof system. So the structural system can be put like a skeletal frame system, large panel system, cell system, hollow block system. And in skeletal frame system, we can have low-rise portal frames, multi-storied frames, and slab column systems with shear walls. So in a skeletal frame system, those which we see in conventional day-to-day life, they are more or less a skeletal frame system. And the suitable buildings are schools, industrial building, commercial building, parking structure, airport terminal, storage facility. So you can see here, this is a heavy engineering workshop in Hazira. So there's a lot of precast elements are here. Now this type of construction with the conventional in situ construction would have been quite difficult. So you can see this is also precast construction, everything. More or less it is complete precast construction. So this is one of the examples. This is terminal building of Bangalore Airport. Again, a precast construction. You can see the shape and size, which is difficult to achieve with conventional in situ construction. Material storage shed in Patna, Nehru Stadium in Chennai. Large panel systems, here the panels are load bearing, and the advantage are close partitioning or space can be achieved. Smooth surface finish, insulated panels, proper joints. And suitable buildings for large panel systems are residential building, miscellaneous type of dwellings. So here you can see these apartments in Mumbai which are made of wall panels. So they are more or less wall panel type of construction. You can see the wall panel systems for construction. Then you can have cell system also. Orthogonal slab and wall are cast together as integral unit to create box type structure. They are suitable for enclosed spaces and can be used as subsystem, system within another system. They are suitable for dormitory, hotel, studio apartment, barrack, lift shaft, kitchen, bathroom, closet. You can have hollow block system also, but of course it's very old. People used to have, then they shifted away from hollow block system. Again, people are talking about hollow block system because nowadays the quality of construction is improved. Otherwise, 2 decades back, there was a lot of talk about hollow block construction. but the construction cost, construction quality was not that good, and the thickness of elements was very small. So if the quality was not good, there were a lot of failures. But now again, now sophisticated machines are available. So people are moving to the solo block system. You can make systems for lateral load resistance like shear wall, etc. And here you can have low-rise portals and frames like cantilevers fixed to foundation. So you can have cladding panel with opening, precast socket footing you can have. Then you can put a precast column here, cladding panel, beam to column connection. So different type of activities are possible. Portal, you can make a portal made of sub-assemblages. So portal can be made in two parts, like here you are seeing. This is one part and this is the other part. So this is A-frame top piece, this is the top piece, and this is second part is the bottom piece, and then you can have pad foundation, etc., purlin. So in different parts you can make a portal with sub-assemblages, different parts. And multi-storied frames also you can make frames with rigid beam to column connection. That is what you need to ensure. So this is a typical frame with rigid beam to column connection. So columns, grouted sleeve, then beam to column face. Here you have to ensure the connections. Beam is put on haunch, and here it is deep column corbel. So different type of connections have been shown here. So you can have multi-story structure also with all the, here 10 to 15 different type of connections have been shown. Here there's like a continuous beam going over column head. Here beam is, the column is continuous, beam is discontinuous. Here beam is continuous, column is discontinuous. And different type of connections. Here this is a different type of connection. This is different type of connection. And this is also different type of connection. So the point is you need to work on those type of connections, but the entire this building construction is possible, multi-story. You can have frames with dry jointed beam to column connection. As the name says, dry connection means you need not do any in situ construction there. You don't need to cast something there. So for that, you need to have like this corbels, etc. So you can make your elements like this. And similarly, you can have wall systems also. So different walls systems you can make using the composite construction, this precast construction. Floor systems also, you can have different type of floor systems. You can have multiple one-way precast units. And so you can see here, and what is important is when you are talking about the floor systems, we always know that in our entire structure engineering, whatever we analyze, whatever we do, we have one very strong assumption, and that is the diaphragms are rigid. That is, there is no in-plane deformation in the slabs. So in the floor system, it is very important to look into that aspect, that your floor slab should be such that it satisfies that requirement that diaphragm is rigid. So that is very important. So one need to understand that to keep the diaphragm rigid, and different type of interventions you can do. Then roof systems are also different type of roof systems can be used. Like here you are seeing slab units on trusses, slab units on truss purlins, here slab units on trusses again. So different, here you can see slab units on arches in vaulted roof, this silo. So you can see these are slab units, different type of slab units, and they are placed on sort of arches in a vaulted roof. So you can have multiple type of constructions. Here you are seeing the shell units, they are placed on the girders. This is again the terminal building of Bangalore Airport. You can have precast floor systems also. Then you can have precast concrete. If it come down to the now components, one is beams. So different type of beams can be used, number of beams, and similarly columns. Now what is important for columns is because the beams will be placed on the columns. So it is very important to see that the beams, they can be placed properly on the columns, and the connection is the sort of proper connection. I think there are certain queries, and I will come down to those queries one by one. So just once this is finished, I will come down. So the columns, what is most important is how we are going to place the beams on the columns. So that is very important. So you can see different types of columns. Like here, you can put the beams here. You can put the beams here. Here you can connect the beam like this. Here you can put the beam here. Here you can put the beam here. So different type of columns you can make. The idea is you have to place the beam safely, and the way in which you are placing the beam, it should be, the analysis should be like that. If I'm placing the beam here like this, then it's, of course, it's going to be sort of like a simply supported beam or the joints are thin joints. But if somehow I pass the beam through this column and then I do some wet casting here, then maybe I have to design as a rigid jointed member. So that is what we need to do. So you can see here the girders with gutters, and through girder also you can see the Y-shaped column which we see here, this Y-shaped column. So through this Y-shaped column there is a through girder which is going on. So they have their own floor units. They can be a plank, they can be hollow core unit, they can be ribbed slab unit, single T and double T units, waffle slab unit, composite slab units. So like these are hollow core slab units, these are double T units. So you can see double T action here. And you can have biaxial hollow slab also. You can see there's a hollow slab and there's some biaxial hollow balls have been put here to reduce the weight and to have more rigidity. So you can have waffle slab also. So depends. And trusses for warehouses, you can see shell units. You can have such shell units also. You can see which by conventional construction is not possible. So in case of roof units, we know that similar roof units, floor units are defined for use. You can have purlins, roof girder, trusses, arches. So even these precast concrete trusses are also available in the market. You can go for this type of truss, arch type truss, triangular type of truss. You can have them readily from the market, from the casting yards. And here, like just a table has been given to just infuse the confidence that this pre-stressed type of truss with 32-meter span was used in Punjab University way back in 1968. So different type of trusses can be used. Of course, that time it might be that it would have happened that it might not be precast construction, but nowadays we can do all sort of precast construction. Wall units, we know that there can be two types of wall units. One is load bearing or structure panel, other is non-load bearing or non-structural panels. So these are load bearing panels which will take the loads, or we can have facade panels. Foundation unit also, what we need to do in foundation unit, it need to take load of column, etc. So we can have socket units or pad and pedestal units. So this is how we can have the foundation units here. And we can even have pre-stressed spun piles and miscellaneous application units, stair units, balcony units, lift shaft units. This is like formwork for precast staircase. You can see precast staircase here. So you can see erection of precast staircase also. So, what is more important actually in case of this precast units is connection, because if you are not able to have proper connection, then your entire design can be a failure. So connection and joints, there can be different type of connections, we know, column or wall to foundation, column to column, beam to column, beam to beam, slab to slab, structural steel work. So we need to work on those joints. Distance point of view, the building should act as one. So it's very important to have a proper connection so that the entire building becomes a single unit. It should not behave in isolation. And thus it is clear that all aspects of component design and structural stability should be dealt with simultaneously in designer's mind. And the structural stability again is most crucial issue because it involves design of both precast concrete component and connection between them. So we need to work on stability, robustness. Stability means adequate resistance against side sway, and integrity and robustness means correct joint design, attention to details, and prevention. So these are the keywords: stability and robustness if you are working for precast construction. And they are scrutinized by checking authorities more for structural stability, integrity, resistance against abnormal than for design of individual precast components, which usually have adequate factor of safety. So it is very important to understand that normally it's not that we have got the precast components, our building becomes safe. Because when the precast components are made, we do agree that they are made in the factory and there's a lot of quality control there. But in the end, if they are not seen in totality in the entire building, how they're acting, and the total behavior of the building, if you're not able to see, then there might be problem. So it's very important to see the structural stability, integrity, etc. And the problem is to ensure adequate ultimate strength and stiffness, but more importantly to ensure that failure mode is ductile. And we know that from earthquake resistance point of view, the failure always has to be ductile. So we need to design the joints like that, the failure is ductile. And large factor of safety are less relevant to overall performance criteria. The point is you can have wonderful precast elements with a factor of safety of 5, factor of safety of 10, but in the end, when they are being put in the building and they have not been put in the building properly, then that factor of safety doesn't carry any meaning. Finally, it is the factor of safety, the entire building. So it's very important how you place them and how you connect them together. What are the challenges in precast construction? So you can summarize that one is the execution of prefabricated building is a complex task with a specific time schedule and competent technical skill. Production technology and erection of component is inseparable activity. So you have to work in harmony, in synchronization at the site as well as off site. And combined, there's a combined and simultaneous involvement of architects, designers, mold specialists, foreman, contractor, and planning person. So a lot of involvement of many experts. So you need to have a proper coordination. No conventional project can be suddenly switched to precast construction. This is a mistake which some people do, and there were some very good buildings also, where people in between they shifted from the conventional construction to precast construction. Later on, there were a lot of problems. One of such buildings was like in Agra, on which I have also worked, when they faced the problems. So that normally we should avoid. Otherwise, what happened there is the building was designed as a conventional in situ construction building. Later on, they tried to put precast elements there, and then there were certain cracks and failures in precast elements. So that wasn't the problem of precast construction or precast elements. That was the problem of the design philosophy. The design philosophy was something different. The elements were something different. So that should be avoided. We should not be like that if we get convinced that precast construction is good and suddenly in the ongoing building we start going for precast construction, which otherwise has been designed as an in situ construction. The alterations in design may result in huge investment and loss of time because you have to make your molds and everything like that. Joints and connections are very important part of the for weak zone in the project. So it is very important. If you miss out on one joint, then your entire project may fail. And again, because as I'm talking, your individual elements might be extremely good with a very good factor of safety. But in the end, the joints and connections should be in such a manner so that you get a good building. And these structures are more sensitive to dynamic loads, hence the safety of building needs to be checked adequately. Dynamic load, why we are saying, because in dynamic load, there's a movement of the building and there's a stress or there's a failure. The zones of failure are the joints, and joints are the weakest part in precast construction. That's why they are sensitive to dynamic load. And then there is a high initial cost of factories, transportation, logistic, lack of skilled labor, which are other causes to have a slower growth rate in India. And no robust analytical tools are available for precast and prefabricated building as such as on now. A few cases you can see this like precast housing in Jamshedpur, hybrid construction, tunnel form on 3 sides. This is view of fascia wall. You can see here precast building with precast footing, columns, wall panels, roof and step units. And you can see here because the joints were not proper, so this school building is with collapsed precast RC panels. So the panels have fallen down. So you can see there is no crack, no failure in the panels even after falling down. That means individual panels or individual elements are very good, but in totality they could not work. They could not deliver the results which we expected. Then this Ocean Engineering Center, IIT Madras, here you can see precast roofing system with V-shaped folded blades. And here is this Q complex at Tirumala. Again, this is a precast construction. So Parliament Library building also is a precast construction. So you can see different these elements, they are precast elements which have been placed later on. This is L&T building. Again, a lot of use of precast elements. So this is 4-story plus steel plus ground supported on 2 columns like 3. So again, a lot of use of precast elements. This Cyber Towers, Hyderabad. So there are 40 mm thick precast vehicle slabs which have been used here. And Passenger Terminal building, Bangalore. Again, here we are seeing this again precast and L&T again. So, so different type of buildings are there in India where people have successfully used this. This part we have already discussed. Specification of precast elements commonly used in India. So the table I already shared. So depending on the span length, you can decide whether you should go for precast element or you should go for cast construction. Sometimes you can take change also, like if you are hell-bent to go for precast construction, you can change the type of element also. So these are different type of elements. So that was about the precast construction. So there are certain queries. Shall I first complete that composite construction, or what's the time now? Okay, let's first discuss this. Yes. Yes. Rajan?
Sir.
I think there are certain queries, so I would like to reply to that.
Sir, we can address the queries at the end of the presentation.
Okay. So we need to.
Yes.
Wait. Share. Okay, so now I'll deal with a specific type of construction. That's the steel concrete composite construction, a specific type of precast, or you can say prefab construction. So the steel concrete composite construction, again, here what we do is mostly we have the girders of the steel and other beams of or slabs of concrete. It can be vice versa also, but most common is steel girders and concrete slab, etc. And what is the advantage is we have a speed of construction here because the steel girders, they don't require any casting or any operations at the site. There's a flexibility and adaptability with the steel girders or the steel sections. We can go for larger spans. There's service integration. Quality is better because the steel we know is always better quality control. Safer construction. We don't need to do many things at the site. There are environmental benefits. We need not fine aggregate and coarse aggregate. We need not excavate them. Higher degree of prefabrication because most of the equipment, most of the parts or elements, they are taken away from the factories. So there's a higher degree of prefabrication. The public damage due to loss in time, route diversions, etc. There's minimized. You might have seen many times nowadays when the bridges, they're crossing the running roads, then they hardly stop the traffic only for 1 day or 2 days because they're putting the precast, or not precast, but they're putting these steel girders there as a bridge girders instead of conventional in situ construction. So more or less, even in small towns, you will see that they don't disturb the traffic now on the running roads, even while doing the construction there because of use of this type of construction. This is a conventional steel concrete composite construction where you have a steel girder and you have profiled slab and you have steel, your shear studs. These shear studs connect the steel girders to concrete slabs. So this is a typical construction. So you can see here steel girders, shear connectors, and this welded wire fabric and a bit of concrete cast here. Of course, nowadays people have precast concrete slab also. So there's a complete prefabricated construction also. We'll come down to that also. Again, from a different angle, it looks like a steel girder, profiled sheets, and concrete slabs. So you can see from other angle, steel girder. This is a stud shear connector, and this is concrete slab. Again, different angle. This is a real photograph. You can see here below there is a steel girder, and then they have put profiled sheet here, and these are shear studs here. Later on, they will put the concrete here. So the concrete will be connected to the steel girders through these shear studs and through this profiled steel sheets. You'll see there are certain undulations on these steel sheets. They are just to make a better connection between the profiled sheet and concrete. So advantages we have already discussed, and disadvantages we see. One of the disadvantages is shear connection installation because you need dedicated manpower and skilled manpower to have these shear studs because they are the reasons for stress concentration. There is a lot of stress here. You cannot go with the conventional material of steel connection here. So they are high strength steel connectors and they have separate, they need dedicated or separate type of welding. The conventional welding does not work on these studs. So this is how a composite metal decking looks like. So you will see here there's a deformed ribs and you will see the deformations on the ribs. They allow for a stronger bond between the concrete and the decking. So you can see the deformations here. So there might be deformations and there might not be deformations. It doesn't matter. But yes, of course, if the deformations are there, the bond is going to be better. So this is here you are seeing like a sort of this profile sheet without deformations. It doesn't matter. But here the bond will be less. Of course, this is going to be better if you would have used this. This is like non-composite metal decking, so you don't see any sort of deformation here or ribs here. Installation of decking, metal decking is placed on the structure still at predetermined points in sequence so that the stud connectors can be welded. This is how shear connectors look like. They are commonly referred as studs. They are available in range of size. There's a IS code for them also and a Euro code also. So there are there are companies which supply the patented shear connectors And this is very high strength steel. Its strength is more than 2 to 3 times of the conventional steel. So because they are going to take a lot of shear between the steel and concrete. And they create a strong bond between steel beam and concrete floor slab, which is poured on the top of metal decking. And so this is how it looks like shear struts. So without deck, it is looking like this. So you can see very closely stressed shear struts. Of course, here there's a lot of load which is expected. Otherwise, normally shear struts are placed at certain distance apart. Placement of concrete. So there's an art of placement of concrete. Because if you put the concrete initially on one side only, then there will be deflection on that part. And so that may change the behavior of the system. So you have to be very cautious, and accordingly you have to place the concrete so that there's no deformation as such, permanent deformation in the sheet. Because we know once the concrete is cast, once it hardens, then the strength will be more because it will be a composite section. But before that, it's not a composite section. The total load is being taken by steel girder and profiled sheet only. So you have to design for that case also, when there's only steel girder and profiled sheet and the load is there. And then you have to design for that also when there's a steel girder, profiled sheet and concrete slab, all three working together as a composite construction. That of course will have less deflection, but somehow if more deflection comes even before that, when the structure is not, when the element is not composite element, there's only steel girder and this profiled sheet without the help of concrete slab, but with the load of concrete slab, there might be permanent deformations. Those permanent deformations we have to handle, we have to avoid. And the concrete construction joint should be located over the beams or girder webs. And so this is how we need to check. And quality control, what we can do, we can weld 2 sample struts sometimes and perform bending tests, etc. So there are different series of tests which are given in Indian standard tests and codes also, like push-out tests, etc. So before going for these shear connectors, we need to do a lot of testing for these shear connectors. Once we are sure about their quality, only then we should move forward. Otherwise, if the connection is not proper, then it will not be a composite construction. It will be sort of like concrete slab placed over a steel beam without any composite action. So it's very important. The role is very important. The better shear connectors are there, well-placed shear connectors are there, more composite action will be there. Then scheduling of composite construction is also very important. And what is advantage in this composite construction, you can see here, simultaneously the work is going at 3 to 4 floors. So that is not possible in case of conventional in situ construction. So this scheduling can always be done for a faster construction. Cambering is done sometimes in steel beams. It is more or less like pre-stressing of concrete girders, where we know that the final deflections will be coming in a direction. So we pre-stress in such a manner that the initial deflections are in opposite direction. Same can be done here in steel girders. So we can do a cambering. So here you can see initially the cambering is like this. There is upward deflection, but we know once the load will be there, so it will be leveled down. So this cambering it is synonym. You can say it is as good as pre-stressing of concrete. So that cambering can be done in steel girders, but that has to be very cautious and very judiciously used, because we know in pre-stressing also it's very important to handle pre-stressing, because it can go other way around also. So it may happen if the proper load is not coming, it will always look like this. So it will have no advantage. So what is the final load and what is the final deflection which we expect? Everything needs to be calibrated and to be handled very properly. So this is how cambering is done. It is done by heating also. And there are of course certain disadvantages like there's a complexity in detailing, fabrication, etc. So you can see here different type of, so here it is given when we should not camber. So when there are cantilevered beams, moment connected beams, brace beams, in that case we should not camber. And beams may be cambered by applying heat to small waist shape area. So you can camber it like this, or you can camber in a, like here, if you heat there, then we know that as a structure engineer, there will be stress distribution, there will be deflection in opposite direction. So you can camber it by heating, or you can have, so these are the marks which are shown here, or you can have a heating cold cambering also. So both type of cambering is there. Natural mill camber can also be achieved the way you take out the from the yard to the site, the way you place the steel girders. So there will be natural cambering. Here you can see the loads are coming in this manner. These are the support conditions. If you change the support conditions here, the deflections will be different. So this natural mill camber can also be achieved. And this is how the cambering is shown actually. Like here it shows 3 by 4 inch camber is there at the center. Here it shows 1 by 4 inch camber is there at the center. So this is how we define the camber. Quality control, we know cambering, there's an American Institute of Steel Construction Code. So accordingly, we have to see the quality control. Cost of cambering, anyway, we have to check it. The final advantage, it is same like pre-stressing. We cannot pre-stress every beam, every concrete beam of 3 meter, 5 meter. So there's a cutoff point for the costing. So here also there's a cutoff point for the costing. If we, the other type of construction which is more towards prefabricated construction is here. Along with this steel girder, we have precast slab also. So now it's much more better. Now there is no in situ construction there. So nowadays people are going with this also, composite beam with prefabricated concrete slab. So different, like we can have hollow core slab, and the different type of shear connectors out there. So like you can have shear studs. The idea is just to have a connection between steel and concrete. So you can have different type of shear connectors, different type of composite columns. Some of the examples like of composite construction in Millennium Tower, Austria, 55-story building, total height 202 meter. And so a huge building, which is a composite construction. Only in 8 months they constructed this building, which otherwise is not possible. 55-story building in 8 months is not possible with the conventional construction. So that was because of the composite construction only. Here you can see these are composite slim floor beams, these are composite columns, and this becomes a composite frame. So this is its plan. And similarly, so here you can see total time of erection was 8 months and maximum speed was 2 to 2.5 story per week, which is not possible with the conventional type of construction. So this is how they work. Similarly, Citibank, Duisburg, 15-story building, total height was 72 meter. And you can see it's also more or less composite construction. Parking deck at one place, so 4-story. And here also it was a composite construction, complete composite construction. So this is the way they put, and they erected composite columns of over even 2 stories. So in conventional in situ construction, we know even 4 to 5 feet maximum we can cast the concrete column in a day. But here it is like 2-story column they have put it straight away. Not only single story, 2-story column. So you can see that multiple simultaneously a lot of work is going on. So at this floor also they are working, at this below floor also they are working, and it's just 2-story column. So simultaneously working at different floor levels. So this is what you can do with composite construction. Then if you see the typical characteristics for building constructed in a composite manner in Hong Kong, they're different, like they use RC core as inner tube, they provide rigidity, etc. And so different type of constructions are possible. So here you are seeing inside there's a RC core, and outside these are columns, and then they are connected. So these type of buildings, they're not possible with the conventional construction. So you can see this, this is the RC core, and this is the connection of from RC core. There are the steel girders which are going, and these are steel girders are connected to outer part. So this is how you connect. And this, you can have concrete filled steel column, also another type of composite construction. So this is steel column which is being filled by concrete. And you can have square sectioned column also. So here we infill the concrete through this. So it can be both way around. Various forms of composite columns. Here you are seeing a lot of these extensions. So these are actually the shear studs. So you can have different type of composite columns. So you can see steel girders are there inside. And then there's a reinforcement placed here, formwork is placed here, and now these steel columns will be enclosed in concrete, whereas here it is concrete is there in steel girder. So it is both way around. So you can have both type of composite columns. So you can see here the composite columns with the studs, and they're comprising of thick fabricated steel section encased with reinforced concrete. So it's both way. We have seen both the figure. Then you can have composite columns forming the mega columns. So 1, 2, 3, 4, 5, 6, and all columns they are connected together. So in the end they will form a mega column. So this type of construction is also there. And this inner core, this will be connected to this mega column. So this type of composite construction is also possible. Here you can see this corner steel post is embedded in the core wall, and here again studs are there. One of the disadvantages why people don't go for the steel construction is normally the fire resistance, because the fire resistance of steel construction is very small. So nowadays what people do is you can encase the structural steel element with concrete. You can cover the elements with fire resistant boarding. We can cover element with fire resistant plaster also. So that disadvantage also nowadays more or less people have come up with the solution. So you can see different type of these composite columns here. And typically if you see like from a structural point of view as an engineer, this is how it looks like: steel beam, struts, etc. Sometimes it do happen that there's a damage in existing concrete slab of composite beam. So there are higher tensile stresses. Because of higher tensile stresses, aggressive environment, excessive loading. So what you can do is you can strengthen the slabs also. What you need to simply do is you can replace old slab with new precast slab. And in fact, you can go with the strut connectors, or you can use adhesive also. So they will give you continuous connection, less stress concentration, no corrosion of connectors. You can control the time dependent effects, and the smaller time will be required. So it is how it looks like that. Normally what we do is pockets are filled with, these are connectors. We put precast slab like this, then we fill them with this grout. And what happens then, there's a cracks, these cracks. So to avoid these cracks, what we can do, we can even connect the concrete slab with the steel girder by use of adhesive layer also. So, and then one interesting study was carried out by us. That was that what is important is when you are attaching this precast slab to the steel girder, if you put the precast slab in a casting yard for a longer time and then you attach the steel girder, it will have lesser time dependent deformations. The reason is simple: there is a lot of creep and shrinkage which takes place in concrete with time. So if the concrete is placed freely, and if you allow the creep and shrinkage to take place in a free concrete, then it will not have any stresses or deformations. But once it is connected to steel girder, and then if you start putting the forces on the concrete, if you connect it with the steel girder at early age, and then creep and shrinkage take place in these composite girders, then there will be a lot of deformations in the entire beam. So what we try to see that if we have this type of bridges, and if we simply delay the time of placement of like these are the moments, this is the percentage change in moment normally which happens due to creep and shrinkage. So what we do is if we just change the time of age of precast slab. So here the age of precast slab is 7 days, here the age of precast slab is 365 days. So if I change the age of precast slab from 7 days to 365 days, if the change in moment would have been 35%, the change in moment is now just 15%. So I can reduce the change in moment by 2 times. And what was more interesting was in case of deflections. So the percentage change in deflection, if I use 7-day-old precast slab is say more than 100%, but if you use 365 days old precast slab, then the percentage change is only 65%. So I can reduce the changes in deflections and moments by huge amount just by delaying the age of the element. It is more or less like when we are using wood in our houses for construction or wooden doors, etc. We allow the wood to season so that there are seasonal variations are not there in the wood. Same is with precast slab. If you put the precast slab in the casting yard for a long time, the creep, shrinkage, and time-dependent effects will take care by there only in the casting yard, and later on they will not cause time-dependent deformations of these moments. Here we can see the market share of composite bridges with the span length in France is more than 90%. And so it's increasing over the world. And we know that in RDS also, railways also more or less they've defined a span range. I think mostly it is from 15 meter to 30 meter, where they have suggested to go for composite construction only. So this is picking up right now in India, particularly composite bridges. So we can need to work into that. We need to work into that. And what is the future in composite construction is we can work on high strength weldable steels, high strength concrete, rolled plates of variable thickness. We can work on control of concrete slab cracking, external pre-stressing, better launching technique. We can work on conceptual structural design like double composite action through upper and lower slabs, corrugated steel webs, precast concrete slabs. We can work on new type of shear connectors like adhesive shear connection. We work on external longitudinal pre-stressing. So these are some of the areas in which we can work in India on the composite construction. Yes, now any questions? I hope I'm able to clear.
Am I audible, sir?
Yes.
There is one question from participant, Zair Ahmad.
Just a
The
minute.
question is, want to know in case of structural health, monitor which are the experimental tests to be carried out in the pre-stressed concrete bridge oblique structures.
So that is not related to this. You are talking about structural health monitoring.
Okay, sir.
No, I can answer that, but I think that's not related to this. So the question is about structural health monitoring. But can you repeat the question?
What to know in case of structural health monitoring, which are the experimental tests to be carried out in the pre-stressed concrete bridge oblique structures?
No, it actually depends. Structural health monitoring is a very big area in itself. But more or less, as a structure engineer, more or less, we are always interested in at least in deflection and cracks. So if you ask me, the number one parameter is deflection at multiple locations. Number two parameter is cracks at different locations. And then there are multiple aspects which can be captured. Yes.
Okay, sir.
Any other? So there are certain queries written here. I can go, I think. Meenakshi has written for in situ construction 28 days required to gain full strength. What about precast construction during earthquake, precast construction performance? So this was a question raised by, I think, Meenakshi. And I think that I have answered in this composite construction slides. Yes, in situ construction, 28 days is required to gain full strength. But in precast construction, we have very good casting yards with all steam curing, etc. So maybe sometimes we can get the same strength in 1 day or 3 days at the most. That is one point. And even if you, otherwise it is suggested to keep it in the casting yard as long as possible. Otherwise, conventionally you can go for this steam curing and you can achieve the same strength in maximum 3 days. So you don't need to wait for 28 days. And what about precast construction during earthquake? There's a code, complete code on this. Yes, there are certain interventions which are required during earthquake. Because in earthquake, the joints are the most weak parts, and the joints are most weak part in precast construction also. But once we design the joints properly, then they behave as good as the conventional in situ construction, the precast construction. Yes. Then again, Ashish has asked, this prefabricated structure earthquake resistant or not? Yes, more or less they are earthquake resistant. It all depends on the joint detailing. If you do good detailing, then they're earthquake resistant. And if you don't do good detailing, they're of no use. They're worst in case of earthquake loads if the joint detailing is not proper. And they are very good if the joint detailing is proper. So ultimately, it comes down to joint detailing. Meenakshi has again asked, is precast construction cheaper than in situ construction? You cannot say it like this. It depends on the scale and it depends on the repetition of the elements. It depends on the casting yard, location of casting yard, and so many things. But yes, if the construction site is large and if there's a repetitive construction, and then it's going to be cheaper. Deflection limit in precast same as in situ. No, different deflection limits are defined in the standard course. Then Dr. Snehal, okay, Dr. Snehal has asked something else. What is the role of shear connector? Role of shear connector is very simple. If this is steel, I hope you are able to see my video. This is steel girder and this is concrete slab. So if you don't have proper shear connector, then this steel girder will behave differently. Concrete will behave differently. To keep them, to make the composite action, shear connector has to come into picture. So shear connector, in fact, is the most important part. It will connect the steel and concrete. It will allow the transfer of shear stresses from steel to concrete. If the shear connector fails somehow, then it's not that. Not a composite construction. In how many ways we can study the economics between in situ and precast? There are a lot of ways actually. It depends. Like there are more than 10, 20. You can see you have to do the complete calculation. But yes, more or less the transportation cost, the distance, the repetitive parts, the molds, etc. That is very important. Otherwise, it depends. You cannot define the parameters offhand. In precast construction, what type of support considered? I'm not able to get that point. Which type of support? I think you are talking about the joints. If you're talking about the joints, you can make your joints pin joint as well as you can make your joints rigid joint. The only idea is if you're making your joints as pin joint, then design the elements also. It should not be that the element has been designed as pin joint and in the field you make it as rigid joint. or the element has been designed for a rigid joint, and in the field you make it pin joint. So whatever purpose it has been designed, the element, the same type of joint has to be ensured there. And both type of supports are possible, rigid as well as pin. What are the codes used for shear connectors? I think I will later on transfer, tell this to Rajan. Right now I don't remember as such, but there are IS 11. I need to look into that. Can you look into that? IS code for shear connectors. I'll let you know. Then guideline rules of IS code and NBC in specimen. Yeah, there are a lot of actually the complete model, so we cannot cover it here. That will require at least one day. But there are a whole lot of guidelines given, like what should be the diameter of shear connector, what should be the height of shear connector, what should be the spacing between shear connector, longitudinal spacing, transverse spacing, etc. Can there be a problem of water leakage in case of joints in precast construction? Till some time back there used to be, but now there are certain sort of construction techniques where there is no problem of water leakage. In fact, sometimes it is far better. Like previously what used to happen, like if this is my ridge and if this is my one profile sheet, this is my other profile sheet, I connect them here. I hope you are able to see my video. If I happen to connect them here, then I have to put the joints here. What they do, they will put one sheet here, and then they will just use some mechanism, some mechanical device to just punch them together. So now there are jointless, in fact, jointless precast roofs. So that's not a big deal now. To bring the technology of using precast construction, what steps can be taken? I think there can be a precast casting yards. One very important part is to make precast construction successful is first people have to be educated about the modular construction, that they should go for same type of construction. You cannot, your precast construction will not be successful if you are going for different type of houses or different type of building. That is one. Of course, people may have certain concern there, but you can begin with like this paver blocks, and then you can begin with like precast solutions for like say manholes. Then even for drains, you can have precast solutions for drains. Like you can provide precast drains of 6 feet length each, 10 feet length each. You can provide precast slabs for concrete paver, concrete roads, etc. So you can begin from there where there's more government involvement, and later on people will go towards that. Can we go for conventional curing for composite construction? Yes, you can go, always go. What's the code? 3935. I think the IS code is 3935 for this IS 3935. IS 3935 section 6.4 for this composite, this shear connectors. Can we go for conventional curing for composite construction? Yes, you can go, but then it will not be economical. For joint connections and what are the techniques that are followed, especially to avoid shear? Actually, there is a complete literature available on that. You need to refer to that literature. There are complete books available. We cannot cover this. But yes, there are hundreds of techniques by which we can make the joint rigid. Which software is more suitable to analyze and design tree? Actually, there is no software like STED or whatever conventional software cannot be used. There are certain software which are used by Europeans, but right now what we need to do is more or less we need to make our own Excel sheets, etc. to analyze them. Usually at what distance we have to provide chamber? Okay, you're talking about which case? It depends on the design. We cannot say like this. But if you say like in case of this sewage lines, then maybe 30 meter or so. So there you can put your chambers, etc. What does prefabricated mean in construction? Prefabricated means your elements have been fabricated in the casting yard. And prefabricated structure means those structures which are using prefabricated elements. Clear? Prefabricated elements are those elements which are already fabricated in the yard. And prefabricated structures are those structures which are more or less using more prefabricated elements. Otherwise, there are always certain prefabricated elements in our building. Composite construction is prepared or precast construction is prepared for earthquake resistance. It depends the type of joints. Again, it comes back to joint. Will the building be safer in earthquake areas with shear connectors? Yes, it will be safe if you have designed the shear connectors properly as per Indian standard codes. For precast members, what precautions are to be taken in case of seismic load? As such, precast members are not going to fail in seismic load. You have to just take care of these joints. That is important. Do Prefabricated have any common code books are there to follow? There are a lot of books on prefabricated construction. Maybe I will share those details with Rajan. Rajan will share with you. Short book on precast and prefabricated construction. There are certain handbooks. Again, I will share with Rajan the details. He will share with you. Okay. Any other detail? Any other query? Rajan? Seepage will affect or not as it's not. Again, I'm just repeating that. Nowadays, there are such techniques that it is more or less like monolithic. More or less, it is like sort of the seepage problem was there some years back. Now there's no problem. For precast joint, I will send the list of books to Rajan. I will share the soft copies of the books, so he will share with you.
Okay, sir.
Okay. So again, everybody is asking about joints. I will share with you because for joints, actually, we need at least 4 or 5 hours. So, because
okay, sir. So shall we conclude, sir?
Yeah, we can conclude.
Yes, because audience will ask so many questions.
No,
actually,
no,
many
okay.
of them are faculties.
No, it's okay.
Yes,
you can share my mail ID also. They can directly
yes,
write also, and I will share the list of books, soft copy of books with you.
Okay, sir.
You can send. Yes, there are Indian codes also, not for prefabricated structure as such, but Indian codes for pre-composite construction. For precast, it is not like directly you will not get Indian code for prefabricated structure. You will get Indian codes on precast elements. So I'll share that, like tolerance limit on precast element, about some other aspects of precast element that I'll share. I'll share the complete link on a Google Drive. I think that is the best.
Okay, sir. Then we will share to our participants.
Yeah, sure.
All the materials.
Sure.
Okay, sir.
Okay.
So I will conclude now.
Okay.
Yes, sir.
Okay.
So
all the best.
First of all, thank you, sir. So first of all, I am very much thankful to Professor Sandeep Chaudhary, sir, working as a professor at Department of Civil Engineering, IIT Indore. So sir has given his valuable time instead of he is having much work at IIT Indore and busy in all the construction of the laboratories and different units at the IIT Indore. So I will conclude the session. I will say that what the sir has covered during his session. So first of all, in the part 1 of the presentation, sir has covered the global and Indian position regarding the construction materials with the use of the precast industries. And then sir has covered the merits of the precast construction. So why we are using the precast construction and why we are going fast with the precast construction instead of having the RCC and other construction, that is old methods. Sir has covered some guidelines from the IS 15917 2010, which gives for the guidelines of composite construction. Then sir has demonstrated the guidelines from the ISO 15916 and NBC section 7 for the modular construction, which is nowadays people are using in the construction industry. And then sir has given the information regarding the precast building systems, then hollow block system, and then the systems having the lateral load connections, lateral load systems and its parts. The portals frames made up of the sub assemblies, that was the very new for us, and then multi-storied frames and frames with rigid beam to column connection. And in that also sir has covered the when beams are the continuous and columns are discontinuous, and in second case when columns are continuous and beams are discontinuous, how the joints are to be given, and the different types of the columns in the precast and composite, that is the column with the corbels, column with the haunches, column with the brackets, and column with the slots. In a new era of the construction, Y-shaped columns are used for laying the girders. So sir has covered that part also, and then sir has covered the floor units of different types with the double shell and double biaxial hollow slabs and waffle slabs also. Precast trusses and pre-stress members are also explained by this sir. So sir, it was a nice presentation, and we learned a lot from this presentation.
I'll just take 1 minute.
Yes, sir.
Just a minute. So,
Yes, sir. So the presentation was useful from the practical point of view for the civil engineering, and it is more of the research point of the view.
Yeah, I think you can always write just for participants. You can all, I think
Okay.
I'm able to share screen. You can always write to me. This is my mail ID and this is my research scholars mail ID. Just this is my
participant can note down the mail ID of the Professor Sandeep Chaudhary.
Yeah, whenever you are writing to me, just put in CC. This is the mail ID of Sanchit Gupta.
Okay, sir.
So, because then they keep on reminding me that I have to reply to you. So this is the mail ID of Sanchit, and you can write down to this. And whenever you have any doubt, you need any reference, anything, just feel free. All the participants can feel free to write down anytime. Okay?
Yes, sir. So you also share some material, sir. We will
share
to our participants.
I will share.
Okay, sir. So, okay, sir. So at the end, I am very thankful, sir, to you for sharing your time. And from Government College of Engineering Karad and Government College of Engineering Nagpur, we are finally thankful to, and we wish you the best luck.
Okay. Thank you.
Thank you, sir. So we will leave now.
Sure, sir. Thank you.
Yes, sir.